This question is integration by parts, and then we have to prove something. That means trigonometric identities, that is in C3. Let's start with A. We have to integrate x cos 2x dx. Again, this is a very common integration by parts. By LATE, let me write out the formula here. This is no limit, so the formula would be u dv by dx, so this would be uv minus v du by dx. So by LATE, so algebra comes first, trigonometry comes later on, so u is algebra, so this is u. Then v, so since this is dv by dx, so v is going to be the integration of cos 2x. The integration of cos 2x is sine 2x by 2 by the fundamental rule of calculus, minus integration. This would be v. So if this is dv by dx, integration of v is going to be sine 2x by 2, and du by dx, so the derivative of x is going to be 1 dx. So this would be x by 2 sine 2x minus, this would be integration of sine 2x is going to be, first of all let me put the half here because there is a 2 downstairs. So integration of sine 2x is going to be minus cos 2x divided by the chain rule 2 by the fundamental rule of calculus. Since the integration is done, plus c at the end. So if I simplify this, this would be x by 2 sine 2x, this minus and this minus multiplies and becomes plus 1 by 4 cos 2x plus c. So this is the integral. In question number B, we have to use trigonometric identities to break this 2x into x. That means we have to use this C3 double angle half angle rule, that sine 2 theta is 2 sine theta cos theta, and cos 2 theta can be written as either 1 minus 2 sine squared theta or 2 cos squared theta minus 1. Either one would do. What we have to prove here then, that the 2x can be broken down. So let me write it down, left hand side. So x by 2 sine 2x plus 1 by 4 cos 2x plus c. So if I break it down, x by 2, sine 2x can be broken down as 2 sine x cos x plus 1 by 4. Now cos 2x can be broken down either as sine square format or cos square format. So the question is, what is the format that is expected? So in the answer we have sine square, because if you multiply the sine x with the sine x, it becomes sine square. So let's try to break it down like that. So 1 minus 2 sine squared x, and the plus c is here. So this would be x by 2 into 2, so this would be x by 2 into 2 sine x cos x, so this 2 and this 2 cancels, plus 1 by 4 into 1 is 1 by 4, minus 1 by 4 into this is 1 by 4 into 2 sine squared x plus c. So this 2 and this 4 cancels and becomes 2, so it becomes x sine x cos x plus 1 by 4 minus half sine squared x plus c. So if I take something common, first of all, this 1 by 4 is a number and this plus c is any constant, any number, so we can write plus 1 by 4 plus c as another arbitrary constant. Arbitrary constant means put all the constant together, so we don't have to worry about this. So now all we have to do is we can take this as common. I can write this as x sine x cos x minus half sine square x and plus c, arbitrary constant for this two. If I take half sine x common, it would be 2x cos x minus sine x plus c. You can check by multiplying half sine x into this 2 and 2 cancels, it will be x sine x cos x, so this is x sine x cos x, it matches. If you multiply half sine x with this, it will be half sine square x, it matches. So this is proved.